Hello, everybody. Mr. Lake here with another chemistry lecture video. Today, I just want to summarize and reflect on some of the main takeaways that you should have gotten from the Coulomb's Law activity, POGIL assignment that we've done over the last couple of days. So, here are really the two main takeaways that you should have found, just to make sure that everybody's on the same page. First of all, with regards to atomic radius, you should have found that atomic radius decreases from left to right. So as you go from left to right across a row in the periodic table, atomic radius, those values decrease, which means that in terms of size, atoms are getting smaller as you go from left to right. Now, you may have also noticed that they do increase as you go down the periodic table, and there is a reason for that, but we haven't covered the fundamentals enough to really understand why that is. So, we're going to just focus on the left to right trend here, which is a decreasing trend, which is a little bit counterintuitive because as you go from left to right across the periodic table, the atomic numbers are increasing, which means that the number of protons in those atoms is increasing, which means that very likely the number of neutrons and electrons that those atoms have is also increasing. So as you go from left to right, atoms are getting more massive, but size wise, they're getting smaller. It's a little counterintuitive. I mean, that's not how humans work, right? If we gain mass, we generally also gain volume, not the other way around. So, why are atoms different? One thing to remember is that atoms are mostly empty space, unlike humans. So there's a very large amount of distance and space between the very dense nucleus and the electrons that kind of fill the rest of the space. There's a lot of ability for an atom to kind of expand, contract, do that thing um, as necessary. Now, what really explains this, though, is of course Coulomb's law. Because as you go from left to right across the periodic table, protons are being added to the nucleus, which means that the positive charge of the nucleus is increasing. And one thing we know from Coulomb's law is that the force of attraction between things is dependent on the strength of their charge. So if you increase the amount of positive charge in the nucleus, it basically becomes a stronger magnet for the electrons around the outside of that atom, which is going to pull those electrons in closer, therefore shrinking the size of the atom. So all these electrons are sort of hanging out, right? And then if you add protons to the nucleus, it like kind of grabs them and just pulls them in a little bit tighter. And therefore, the atom gets smaller even though it's gaining mass. Now, the other trend that we focused on, which is electronegativity. And just to review, electronegativity is a value that represents how strongly an atom is pulling on electrons, how strongly it attracts electrons, which is in reference both to its own electrons, like how strongly the nucleus is attracting its own electrons, as well as how strongly the atom is attracting the electrons of other atoms. Many apologies for my dog. Hopefully he's done. I guess not. So, what you may have noticed is that electronegativity increases as you go from left to right. Now, this makes a lot of sense because, again, you're adding protons to the nucleus. So the nucleus is becoming more and more strongly positively charged, which basically makes it a stronger positive magnet. And so, as you increase the strength of that magnet, it's going to have more pull on electrons, which is the definition of electronegativity, how strongly it's pulling electrons. Now, another thing that we haven't really covered is in Coulomb's law, the relationship between not just the strength of the charges, but how far apart they are. Distance really matters. If you've got two charges that are this far apart, they're going to have a certain attraction for one another. If you pull them further apart, they're going to be less attracted to one another. And if you push them really close together, they're going to be more attracted to one another. So there's this kind of building effect where as the electronegativity of the nucleus increases, it pulls the electrons in closer, which also decreases the distance between the nucleus and the electrons and pulls them in even closer. But even more importantly, it shrinks the size of the atom, which means that that atom and that nucleus can get closer to the electrons of other atoms and attract them more strongly. It's okay if that piece, the distance piece, didn't make as much sense as the electronegativity, like strength of charge piece, because that's really what we've been focusing on. But I'd be remiss if I didn't at least mention it because it's another very important part of Coulomb's law. So those are the two main takeaways that you should have gotten from this: how atomic radius, what the trend is, and how it's exposed by electronegativity, and what the trend is in how it's exposed by explained by Coulomb's law, and what the trend is in electronegativity and how that's explained by Coulomb's law. And the third takeaway is that I have a very, very bad dog that is very, very distracting. Many apologies about that. So that's it for this video. I will see you next time. And until then, take care, everybody.